In this video, we will be looking at a neutralization reaction. Below I've written the definition. A neutralization reaction is when an acid and a base combine to produce water and salt. Water is neutral and has a pH of 7, and salt is not going to have a pH that will be affecting the solution. If you look at number 9, I've already circled the ions that are at play. NaOH is a base and HCl is an acid. The OH from the base is going to combine with the H from the acid to produce water, H2O. And the two leftover ions, Na and Cl, will combine to produce salt. When a substance is neutral, the H plus and the OH minus are equal, like in water. In this lab, you will be looking at a titration reaction. We will be using an indicator to find out when the acid and base concentration is neutral. In this lab, we will be looking at 3 different acids, A, B, and C. The 3 acids are all clear liquids, and our base is also a clear liquid. In this table, we will be filling out how many drops of base are required to neutralize the reaction. So we will be determining which solution is the strongest and which solution is the weakest based on the number of drops. The more drops you need to neutralize the solution, the stronger the acid. The less drops you need, the weaker the acid. So you will be filling in the number of drops necessary. I'm going to just flip to the back so we have a clean background. I'm going to put this on here. I'm going to start adding drops of base, and we're going to notice a color change occurring. 1, 2, 3. So you can already see this light pink color occurring with 3 drops. It disappears, it doesn't stay, so that means I need to add some more drops. 4, 5. We'll swirl it around. And now it didn't disappear. So to neutralize acid A, we needed 5 drops of base. So we're going to fill that in on our table. Our second acid, acid B, will require 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I swirl it around and it disappears. That means we need to add more base. 11, 12, 13, 14, 15, 16, 17, 18. And you want to swirl it around to make sure that you don't put in too many drops. 19, 20, 21. Almost there. 22, 23, 24. So this one needed 24 drops. And our final acid, acid C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Eleven, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Getting closer. 31, 32, 33, 34, 35. So we'll go with 35 drops. I've probably added in too many drops because it looks a little darker than the other ones. All right, so you should be able to answer the following questions. Which solution was the most acidic based on our data? You should be able to support it with evidence from the experiment. And then you should be able to answer which chemicals are in each beaker. So I've told you that solution A, B, and C are acids, so you should be able to tell me the ions that are found in each, and the solution we were adding in was a base. The last question is you will need to research one use of a titration in real life. So this is an example of when would a titration be applied to your everyday life. We don't simply want you to look up the definition of a titration. Before I let you go, we're going to do one more thing. So this is one of our acids from earlier. This is acid B. We can actually undo this reaction. So right now it is pink, meaning that the number of H and OH are equal. If I was to add in more acid, I could actually undo this reaction. So I'm going to pour in some more acid, a clear liquid. And you can see the pink color disappearing. Swirl it around. It's totally gone. If I was to add in more base, so right now there are more H's than OH's. Right now I'm dropping in OH's, and the color change is occurring again.